Now that we have all the clearance for our hardware components, we can start adding the screws. A very important note is that we will not add the screws to 3D print them, but to properly communicate our design and to see that our 3D printable parts are correctly designed. Okay, so we will not create by ourselves the screws and the nuts. We will use a tool called Insert MIG-Master Car Component. This is an entire catalog of bolts, nuts, screws, tape, and other things like bearings and shaft collars and so on. This is a real catalog. You can buy those things. So the idea of the catalog is to test the parts in your design, and if they fit, you can buy them. But before we browse the catalog, we need to see what's the size of the screw and the nuts that we need. Well, the idea of the screw that we'll need for the Raspberry Pi is that it will go from this point to that point and needs to be a little bit bigger so the nut will fit. Let's create a sketch, but we will not save it. We'll just sketch to see the dimension. So let's say that it will start from this point and it will go like this. Okay, so this we will use a 2 or 4 millimeter screw. Okay, this can work. So we will need a 14 millimeters screw. I will finish the sketch and I will click back so the sketch will be deleted. And we need to see the diameter of the hole. That is, let's see, 1.3 millimeters. Here we have a section called comments. Here in the comments section, we can add details like dimensions. So when we browse the catalog, we can see again the dimensions, so we don't need to remember them. So I have the diameter will be 2.7 millimeters and the length 14 millimeters. I'll post it. Okay, and let's go to the catalog, insert a master car component, and let's select our screw. I want a flat house screw with a cross, and I will use a metric system to find the screw. Okay, and I need the length of 14 millimeters, and I will try different screws to see the schemes. If I go to the product detail, I can see here the dimensions. So this screw has 20.5 millimeters diameter and the length of 14 millimeters. It's perfect. I can go to the 3D step, okay, and I click save, and it automatically imported to my design. Now I can use align. So I will go to align. I will select the outer part of the screw and we will rotate it. Okay. And I will move it. I will go to a top view so I can go enough. Good. I can click OK, and we have the screw perfectly placed. We go again to the insert MIG-Master, and we go to the nuts. I will choose a hex nut. Okay. And I need a nut that has 20.5 millimeters. I can go again to the product details. I can see the dimensions that are good. I will click Save, and it's imported to my design. I will go again to the front, actually not before rotating it on this side. Okay, so we can align it. Front, I will use again the Align tool, and now I have the screw mounted, and I will move it a little bit. Oops. So everything is in place. Okay, so as you can see, I have a little bit of space here, but it doesn't need to be perfect. It just needs to be in place, so I can check that everything that I designed, it's okay. I want to repeat again. The screws, the Raspberry Pi, the sensor, and the motor are not here to be 3D printed. They are here to see if that my design works and is done correctly. Now that I have the screw and the nut, we can click Save. Okay, and we will come back when we'll have all the screws for the servo motor, for the rod, for the muscle sensor, and we will continue with other details that we can add on our exoskeleton.